Hello everyone! Welcome again to my challenge problem series, and today it is going to be the second challenge problem series. The problem is, there are a million switches in a room numbered 1 to a million. Initially they are all turned off. You flip all of them on. Then you flip every second switch restarting from switch 1. After that, you flip every third switch again restarting from switch 1. You repeat this process a total of 999,999 times, or in other words, you have flipped switch a million a total of 49 times by the end. How many switches are on in the end? Now take some time to think about this problem. Feel free to pause the video if you want to. Now I'll start talking about the solution. The first important observation we can make is if a switch has been flipped an odd number of times, then it is on at the end. If we think about it, we start with the switch, right? It is turned off. If we flip it once, it is turned on. And if we flip it again and again and again and again and again, since an odd number is 1 plus an even number, and an even number does not change the state of whether it's on or off, since it's twice, then if we flip the switch an odd number of times, it is on at the end. Our second important observation is that the number of times that switch number x is flipped is equal to the number of divisors that x has. If you think about it, for example, when we said that every second switch was flipped, all numbers divisible by 2, those switches would be flipped. And we iterate through from 1 all the way to 1,000. So we don't not include any number. So if a particular number x, the number of divisors it has, well, positive of course, that is the number of times it's flipped, which makes sense. Now I have an important question for you all. How can we tell how many times a particular switch has been flipped at the end? Think about this question. The third important observation is that we know that a perfect square has an odd number of divisors. If a switch number has an odd number of divisors, then it's also flipped an odd number of times by observation number 2. If a switch is flipped an odd number of times, then it's on at the end, which is observation number 1. Well, how do we know that a perfect square has an odd number of divisors? Well, this can be easily seen if we just write the prime factorization of a perfect square. The prime factorization of a perfect square is just in the form of p1 to the 2x1 times p2 to the 2x2 on to pn to the 2xn. Well, if you think about it, the number of divisors of this number, or perfect square, is 2x1 plus 1 times 2x2 plus 1 on and on to 2xn plus 1. And it's all multiplied together. And this number would be odd. It's a bunch of odd numbers multiplied together. But why is it that expression? The reason is because you can choose each prime number to be anything from 0 to 2x1 or anything from 0 to 2x2 and so on. Because of that, that means that the number of divisors of this perfect square will just be 2x1 plus 1 all the way to 2xn plus 1. And that is it. Important question number 2. How many square numbers are there from 1 to a million? Think about this problem for a second. And feel free to pause the video. But now I'll go on to the answer of this entire question. If you said 1,000, you'd be correct. And that is our final answer. Thank you so much for watching my videos. And feel free to subscribe or drop a like. And please do that. Thank you so much.